Alright guys, today we're going to talk about lesson 4.5 in the textbook, and we're going to start with task 1. Alright, so now we're going to be dividing polynomials, and we're actually going to do 3 or 4 different methods that you're going to learn in this section. So the first thing we're going to look at is synthetic substitution. This is not my favorite, but you may like it, so you may want to use it. But we're also going to learn synthetic division and long division, which are both necessary that you learn. So let's get started. Evaluate a polynomial function using synthetic substitution. You have used the order of operations to evaluate polynomials written in standard form for a given value of the variable. Polynomials can also be written in nested form using layers of parentheses. For polynomials written in nested form, the order of operations calls for evaluating the expression from the innermost parentheses outward. The steps to evaluate the polynomial p of x below alternate between multiplication and addition. Alright, so that's important. We're going to alternate between multiplication and addition. And that's also the similar when we do synthetic division as well. Alright, so they show you an example here of a polynomial. So p of x equals ax to the fourth plus bx to the third plus cx squared plus dx plus e. So nested form basically takes your innermost, first it eliminates the e because e doesn't have an x and it pulls out an x from all the other terms. Then it goes to the next layer and pulls out another x because if you don't look at the last two terms, these all have a second x, so it pulls out. And then it goes to the next layer and pulls out another x, etc. So it kind of like breaks it down from your innermost factor out. All right, so you can see ax plus b, and then you've got x plus c is your next factor, and then x plus d is your next factor, and then on the end is x plus e. All right, so the steps, it says for a given value of x, multiply a by x, then add b. Multiply by x, add c, multiply by x, add d, and multiply by x and add e. And you can see they did the same thing over here, just using numbers. So it's got the 5x plus 3 in the middle, and then it's got the x plus 1. When there's no coefficient there, it's a 1. And then the x plus 2 and the x plus 7 on the outside layer. Alright, so evaluating a polynomial function p of x for a specific value of x can also be accomplished by using a technique called synthetic substitution. This technique parallels the sequence of steps for evaluating a nested polynomial. Synthetic substitution uses an array to model the sequence of steps needed to find the value of a polynomial function p of x for any value of x. The nested form of the p of x is p of x equals, and you can see this array of stuff here with all the parentheses. Notice that p of x lacks a linear term. So it went 4, 3, 2. There's no x to the first power, so there's no linear term, which must still be accounted for in the nested form. So you can see they've added a 0 here for the x term. Alright, now it says put the operations performed when evaluating the nested form of the polynomial p of x in order. Alright, so we're evaluating p of x for p of negative 3, and they just want us to put the steps in order. So if you see at the top, it says for a given value x, multiply 5 by x, multiply 5 by x and add 3, so that's your first coefficient, and then you add b, which is your second term. So let's see what our steps are here. So we're going to multiply by the first term. Alright, so we're going to multiply 2 by negative 3. See if I can drag this up here. I have to shrink my screen a bit. Sometimes it doesn't want to work. All right. All right, let's see if I have more room, if it'll work now. So let's drag this to the top. You can see drag and drop is not my best feature. There it is. All right, so I multiplied the first term by the -3. Then I need to add b. So that's from the steps above. If you go back above, see add 3, or add b. Okay, so the next thing I need to do is add 5. And then I start the process over again. So I'm going to multiply by -3 again. And after I multiply by -3, I'm going to add -2. So you alternate between multiplication and addition. So I'm going to multiply by -3 again. I multiply by -3 every other time. Whoops. Let's see, what was that? That was -2. All right. And the reason I'm multiplying by -3 every other time is because I'm evaluating for p of -3. All right, so after I do that, -2, after -2, then there's no linear term, so that means I'm going to add 0. And then I'm going to multiply by -3 again. And then the last thing is add -8. All right, so all we're doing is using the steps above for synthetic substitution. So where it says evaluate the steps, this is what we did right here exactly for nested form. All right, it says what is p of -3? All right, so p of -3, if you use this weird nested form, it helps you evaluate more easily without a calculator. So if you're on a non-calculator portion of the test, then it would help you evaluate for this a little easier using this nested program, or nested, I don't even know what it's called, so nested format, I guess. All right, so we're going to take the -3 and we're going to plug it in here. So you're going to have -3, and then x again, -3, and then x again, -3, and then 2 times -3 plus 5 minus 2 plus 0 minus 8. Okay, so if you want to use the nested thing, then this is what you would do. So you would start on the inside. So this would be -6 plus 5, or -1. And then -3 times -1 is 3. 3 minus 2 is 1. So all of this is now 1. -3 times 1 is -3 plus 0. So that's just -3. And then -3 times -3 is 9 minus 8, which is 1. All right, so I don't love that. I'll show you an easier way here in a minute to do this. But if you don't have a calculator, that is a quick, easy way, if you're good at simple math, to get the answer using the nested program, or using the nested formula, or whatever it's called. All right, so p of -3, we found that to be 1. And then it says consider synthetic division. All right, so synthetic division is something that we are going to practice and learn. So this is one example of that. So it says consider the synthetic substitution array p of -3 for this polynomial. How are the numbers in the top row of the array related to p of x? Select all that apply. All right, so the -3 comes here. We put it in this little box type, and then we bring the coefficients, 2, 5, -2. Remember, we have a 0 for a linear term and -8. So these numbers are just the coefficients from this polynomial. All right, and then we bring the first term down. 2 just drops down, and then we multiply. -3 times 2 is -6. Then we add. 5 and -6 is -1. Then we multiply by 3 again. Negative 3 times negative 1 is 3. Add, we get 1. Multiply by negative 3, we get negative 3 plus 0. Add those, you get negative 3. Negative 3 times negative 3 is 9. Negative 8 plus 9 is 1. So this is the synthetic division, and I like this a whole lot better than the nested substitution thing. But again, you're free to choose what you like the best. All right, so it says the numbers come from the degree of each term. So it's not coming from the degree, it's coming from the coefficients. So the numbers are the coefficients of each term in descending order by degree. So that is true. The numbers include a 0 because there is no linear term. That is true. And the numbers are the 4 individual terms evaluated for each. That's not true. We're evaluating it all together to get the final answer at the end. All right, so that's all for that one. And then it says, how does the framework in synthetic substitution array show the sequence of multiplication and addition using to evaluate the nested polynomial? So again, you could see that you bring the first term down, but then you multiply, add, multiply, add, multiply, add, multiply, add, which is exactly the same thing as we did up here in the nested array. So for a given value of x, multiply, add, multiply, add, multiply, add, multiply, add. So it's very much the same, just looks a little bit different how you set it up. All right, that's all for task 1.